Hello everyone. Today we are learning how to write Python statements in Python shell. In the previous session we learned how to install Python. I hope all of you have installed Python. So let us start with the next thing, writing Python statements. Statement is nothing but an instruction which we will be giving to a computer. So here in Python, anything which we are sending as instruction to the Python shell is called a Python statement. So in today's class, we will be discussing about Python statements where we will be executing mathematic or arithmetic statements. Before going further, let us see how we can run these programs or instructions on the computer. As you can see, computer will not, like computer is nothing but a hardware will not interact with each and every application directly on the computer. Hardware will only interact with the operating system, which is a special software which will facilitate other applications to interact with hardware. So Python and programming languages such as Python, Java and Visual Basic, they have their own interpreter, which is a special software which runs on operating system, and these interpreters let the instructions of that specific programming language execute. So what this Python interpreter do is it converts the Python code into computer understandable language, or the code which can run on operating system, or which helps to interact with hardware. So in Python we can use this Python interpreter in two ways. That means we can run Python instructions in two ways. First one, create a file and save it with .py extension. That is nothing but a Python file, and you're executing a Python file. Or the second way is use an interacting program which is called as shell. It's called as Python shell, where we will type each instruction, one instruction at a time, and the interpreter responds to that instruction. So in today's session we will be learning about Python shell and how an instruction can be executed in a Python shell. So to start with, Python comes with a program called IDLE. When you type IDLE in the command prompt, it will take you to the Python shell. As you can see here, I have checked Python version in the command prompt. Then I'm typing IDLE. Once I type IDLE, one window will open which will be visible like this, a white window in my Windows. Here I can see, here we have this three greater than symbols which are together. This is called as prompt. We will be typing all our instructions in this prompt, and Python responds to that instruction. I hope all of you have installed Python. Now let us move on to Python shell and see how we can execute these instructions. So let us start with arithmetic operations. As you can do in any other interactive shells, you can do in Python as well. 4 plus 13, 15 minus 3, 4 star 7, that is multiplication, division, all these operations, the basic arithmetic operations, can be done directly, and the Python shell responds with the respected answers. One thing we'll have to note here is always the result of division is decimal. Even though the result is a whole number, it will show the result in decimal. Like 4 by 2 is 2. Even though it's 2, it is showing it as 2.0. So the result of division is always a decimal point. Moving on to data types. So Every value in Python has a particular data type. If you're storing some value, each value will have its own data type. But today we will be discussing about numbers and numeric values. So we are learning about integer and float data types. There are only two types, int and float. Float is the short name for floating point number. Int is the short name for integer. So let us see how this works. If your expression involves two floats, the resultant will be a float. And if your expression involves at least one float, whether it's on the left side or the right side of the operator, it doesn't matter. If your expression involves one float also, the resultant will be float only, floating point number only. As you can see here, 17.0 minus 10.0 is 7.0. The same way, if you are making either of these two operators as integer, then also the result will be same. Like you can see, 17.0 minus 10 is 7.0. 17 minus 10.0 is also 7.0. Also, when you're typing floating point numbers, you can omit the letters or the numbers after decimal point. You can just type 17 minus 10 point. That means 10.0 itself. But this kind of typing is usually avoided by programmers, as it's a bad style of programming. It is considered as bad style because while reading, if you have 17 minus 10.0, it's easy to read and understand. If suddenly if you come across 17 minus 10 point and there is nothing after the decimal point, that means it's difficult to understand. So this is considered as bad programming design or bad programming style. Then moving on, the next type of operator is integer division and modulus operator. Integer division means the result of the division operator will be integer and the fraction part will be removed. Here, when division operation happens, the it will not round off to the nearest number, it will round off to the nearest previous number. Like 53 divided by 24, it will round off to 2. 24 into 2 point something it will be, so it will round off to 2 and not 3. 53 percentage 24, this percentage is the modulo operator. It is used to calculate the remainder when 53 is divided by 24. So when 53 is divided by 24, 2 is the divisor and 5 is the remainder. As you can see here also, 17 divided by 10. 17 divided by 10 means 1.7 it will be. But still it rounds down to the nearest previous integer, nearest, not the nearest next integer. It always rounds down to its floor or the previous integer. 17 divided by 10 for integer division, it is 1, minus when you're doing the negative operation, some problem occurs. As it rounds down to its previous number, it will become minus 2. So when you're using negative numbers, using integer division will end up with wrong answers. So please be careful when you're using the integer division and modulus, especially with negative numbers. Exponentiation operation, that is 3 exponential 6, that means 3 to the power 6. Similarly, 2 to the power 2. We can calculate exponential values like this. Then unary operator, that is you can use any of the basic arithmetic operators as unary operator. Here I am using minus. As you can see, it is minus 5, but when I am using 2 minus, it will become minus into minus, that is 2 negations, it will end up with plus 5. Similarly, if I'm using 3, it will be minus 5. 4 again, it's plus 5. So you can use unary operators with binary operators as well in the expression. These are the list of the arithmetic operators: negation operator, addition operator, subtraction, multiplication, division. This negation means the operator, if the minus operator is used before the expression, then it's called as negation. If you're using with in between two operands, then it is called as subtraction operation. Then multiplication, division, integer division, remainder or modulo operator, exponentiation operator, all these things I just mentioned. Please do execute these things in Python shell and see the result by yourself. Now let us see an important concept called operator precedence. Operator precedence. Before going to this, I want to take an example and execute an expression here. So to evaluate this expression, what I am doing here is I have value in degree Fahrenheit. I want it to convert it into degree Celsius. So I have 212 degree Fahrenheit and I want this to be converted to degree Celsius, and when I apply the formula 212 minus 32 into 5 by 9, this is the formula. 212 should be subtracted by 32 into 5 by 9 has to be done. So when converted, my resultant value should be 100. 212 degree Fahrenheit is equal to 100 degrees Celsius. But I am not getting this in Python. What is wrong with this statement? I have given 212 minus 32 into 5 by 9. But again I am getting the wrong answer. This is because the evaluation of the expression 212 minus 32 should be done, and again 5 by 9 should be done, and both should be multiplied. But what Python is doing, it is doing 32 into 5 divided by 9, that is subtracted by 212. So this is giving the wrong answer. So now I have to tell Python clearly that I want the value of the Fahrenheit to be subtracted by 32, then multiply it by 5 by 9. Now when I'm giving the expression like this, I'm getting the correct answer. Suddenly what has changed? I am giving clearly instruction to the Python that do this operation first. Otherwise what happens? Python understands it in its own way. There are some operations which has higher precedence than some other operations which will execute first. So we have to be clear and specific while giving instruction to the Python. Let us take one more example here. I have minus 2 power 4. So now what is being done here is this exponential operation has higher precedence than unary minus operation or negation operation. So it's calculating 2 power 4. 2 power 4 is 16, then negated minus 16. As you can see here also, minus 2 in 2 power 4. So it's minus 60. What if I want to do minus 2 power 4? I'm giving it in the brackets, minus 2 power 4. I'm getting 16 because this minus 2 also is multiplied 4 times. So what changed the result? When you're giving any expression to evaluate, give the expression clearly. Make use of brackets so that there should be no scope for Python to think this has to be evaluated first. You are telling clearly in this expression, this has to be evaluated first. This expression has to be evaluated, or this sub expression has to be evaluated first. And this is a table of operator precedence. Exponentiation has the highest precedence, then negation, then later multiplication, division, integer division, and modulus operators. The lowest precedence operators are plus and minus. But in case if operations on any expression has the same precedence, then the evaluation of the expression takes place from left to right, except for exponentiation. Whenever the exponentiation operation comes, uh, the evaluation takes place from right to left, whereas in all the other operations the evaluation of the expression takes place from left to right. So till now we were discussing about basic arithmetic operations and how the expressions are evaluated. Now let us see, if I want to store some value, store the result of some expression, how can I store that in computer memory? For that, to storing the values, we will be using a special thing called as variable. Variables are the names with which we are associating a value and storing it in the computer. We are giving a name to the variable, or we are giving a name to the value. So this variable name should always starts with either letter or underscore. It can have letter, digit and underscore. No other special symbols are allowed here. It can have only alphabets, digits and underscore. We can see this example here. X can be the name of the variable. Species 5618, that is, it's a combination of characters and number. This can be the name of the variable. Then degree underscore Celsius, this can be the name of the variable. All these are valid variable names. If you're using any variable, use any name which you can relate to the variable which you are associating. That is, use some meaningful name according to your requirement. But you are not allowed to use numbers as variable name, because number is considered as literal and it's treated as number itself. You cannot use any number as name of the variable, and neither you can use this no hyphen way and then exclamation. It contains hyphen and explanation, this exclamation mark, which both are special symbols, and you're not allowed to use any other special symbols than underscore in the variable name. Let us see one example here. I'm creating a variable degree underscore Celsius and equal operator, which is assignment operator 26. So this is an assignment statement. I'm creating a variable with the name degree underscore Celsius and I'm assigning a value 26 to it. So when I just type the name degree Celsius, Python shell will give me the value of this variable. Similarly, I want to reassign the value to this variable. I can just use the assignment operator again. Degree Celsius is equal to 0.0. Initially it was 26. Then I reassign degree Celsius is equal to 0.0. Now degree Celsius value is 0.0. Why I have reassigned the value here is just to show this concept of variable. Variable is having the name variable. This is because the value of these things may vary at any point in the program. This is one of the important thing which I wanted to mention here. Usually in mathematics, if you're a mathematics student, what we understand with this equal sign is, whenever we come across this equal sign, whatever the value will be on the right hand side should be equal to the value on the left hand side. That is, LHS is equal to RHS. But in computers, it is totally different. In computer, we are not using this equals as equality symbol. Instead, we are using this equal sign as assignment operator. Assignment operator means we are giving some value on the right hand side of the assignment operator, and that value will be stored on the variable which will be on the left hand side of the assignment operator. As you can see in this example, x is equal to 12. This equal sign is used to assign the literal value 12 to the variable x. Here it is not LHS is equal to RHS, it is 12 assigned to the variable x. Now variable x contains the value 12. You are not allowed to use statements like 12 is equal to x in computers for the same reason. Whatever the value you're giving on the right hand side will be assigned to the element on the left hand side. So we are storing 12 in the variable x. Now let us see how this is stored. I just mentioned we are storing x is equal to 12 means we are storing 12 in x. So how it is being stored in a computer memory model. So computer memory model will allot a memory location for each of the value, and it has its own address, like we have address of a house or address of any locality if you want. So here I'm storing this 26.0 in the address ID1, and this value which I'm storing this in this address ID1 is of type float. So this is how we draw the floating point value using the memory model. So now I want to assign this value to a variable called degree Celsius. So now degree Celsius is a variable which is pointing to the memory location ID1. ID1 is the memory location where this degree Celsius is pointing to, and this ID1 is the address of this particular memory location. So the value of degree Celsius is 26.0. In Python shell, I'll be giving degree Celsius is equal to 26.0. By default, computer will associate an address with this memory location. Now we are considering it to be ID1 of type float, and then it assigns that to the variable degree Celsius. So what are the terminologies used here? I'm using the same expression, degree Celsius, which is pointing to 26.0. So the value 26.0 has the memory address ID1. Object at the memory address ID1 has type float, and the value 26.0, as you can see here. Then variable degree Celsius contains the memory address ID1. This variable contains the memory address of the value. That means variable degree Celsius is referring to the value 26.0 here. Then I just mentioned about the assignment operator. Let us discuss about the assignment statement. Each assignment statement will have the same syntax. Syntax means the rules which govern the language. Here in Python, we'll be following this general form, which is variable is equal to expression, like x is equal to 12. So how this is evaluated? Variable is equal to expression means expression which is on the right side of the equality sign or the right side of the assignment operator is evaluated. This expression is evaluated, and then the value or the resultant of this expression is stored in the variable given. If I am saying x is equal to 12 plus 1, this 12 plus 1 is evaluated as 13, and 13 is the value we are storing in variable x. Okay, this is one more example we can consider. Degree Celsius is equal to 26.0 plus 5. Now what happens? This assignment operator, whenever we come across assignment operator, right side to the assignment operator is the expression, left side of the assignment operator will be the variable. So here expression has to be evaluated. 26.0 plus 5, that is 31.0. This is evaluated, and this result 31.0 is stored in degree Celsius. Later when you type degree Celsius, Python will give you the result 31.0. You can type these things in the Python shell and practice. let us consider one more example for reassigning the values to variables. So let us consider this code. Difference is equal to 20. Difference is a variable for which I'm assigning the value 20. So 20 is stored in a memory location ID1 and difference is pointing to the memory location of ID1. Then double is equal to 2 into difference. Double means 2 into difference. Difference value is 20. 2 into 20 is 40 and that 40 is calculated and stored in another memory location ID2 and double is pointing to ID2. Now I have value difference equals 20, double equals 40. Now I have changed the value of difference. At this point difference is pointing to value 5. So I've created one more expression and it is stored in the memory location ID3 and difference is pointing to this particular memory location and now the value of difference is 5. Now let me go back and recheck. Difference is equal to 5 and double value remains same as 40. Even though double value we calculated as 2 times the difference, but it was at that particular moment where the difference value was 20. Later, if you change the difference value or if you do not change, that really doesn't matter. The value of double remains same as you can see here. That is, reassigning the value to the variable does not change the value of the value of any other variable. This is one of the special features of Python and it's available in other few programming languages as well. Augmented assignment or shorthand operator. That is, when you're using the variable name which is on the left side of the assignment operator and also on the right side of the assignment operator, you can use a shorthand operator for that. For example, let us consider this. Score is equal to 40. Initially, the value of score is 50. Sorry, not 40. Initially, the value of score is 50. Then I want to add 20 to the existing value of score. So I'm doing score is equal to score plus 20. Now the value of score is 70. So in Python, if you want to do the same thing, you can avoid typing the value of the variable more than once. That can be done by using shorthand operator or augmented assignment operator. That is, this plus and equals can be combined together so that you can avoid this variable name twice. As you can see here, score equals 50, then score plus equals 20. Plus equals is the shorthand notation. That is, score equals score plus 20 can be written as score plus equals 20. Let us see some of the shorthand operators. These are some of the augmented assignment operators. See, x is equal to 7. X plus equals 7 means x equals x plus 7. Sorry, x equals x plus 2 here. 7 plus 2 is 9, so the value of x is 9. X equals 7, x minus equals 2 means x equals x minus 2, that is 7 minus 2, which is 5. Similarly, for multiplication, division, integer division, modulus and exponential operators, so for all these basic arithmetic operators, augmented assignment operators can be used. Then different types of error we usually come across in Python statements are of two types: syntax error and semantic error. Syntax error means when you are writing any Python statement wrongly, that is, according to the language rules, if you are not writing any Python statement, it will throw syntax error. Semantic error means meaning. When you are trying to do something which is not possible for a Python interpreter to do, like divide a number by 0 or using a variable which doesn't exist, all those things will be considered as semantic error. Let us see some examples here. See 3 plus new val. New val is a variable value which I have not defined. I don't know the value, so the Python doesn't know the value of new val. I'm just giving 3 plus new val. So this is a semantic error. Syntactically it is correct. You are trying to add a variable and a literal. But when you look at the meaning, new val value is undefined. So the Python will throw an error, error, name new val is not defined. This is one of the semantic error. Then here is one more example, 2 plus, and I'm not giving any other expression, I just press enter. So this is half of the expression, 2 plus what? You're not giving the second operator, second operand. Sorry for that. So now it is throwing an error, syntax error, invalid syntax. You're saying 2 plus, but add what? That you are not telling. So it will end up with a syntax error. And then similarly, here is one more example. I'm giving 12 is equal to x. So I have already mentioned whenever you are using assignment operator, variable should be on the left side of the assignment operator and literal should be on the right side of the assignment operator. It's not wrong if you are having even variable on the right side of the operator, but you cannot have a literal on the left side of the assignment operator. So it is showing syntax error, cannot assign to a literal. You cannot store any value in a literal, just like you store a value in variable. X is equal to 12 is fine. You're storing value 12 in a variable x. Whereas 12 is equal to x is wrong. It cannot be syntactically acceptable. But what if you want to span a statement over multiple lines? Then you can do two things to span a statement over multiple lines. First thing, write the contents using bracket, like bracket open 2 plus, I've opened a brace 2 plus, then in the next line I'm giving 3 and then close bracket. Until you give close bracket, it will be considered as single statement and statement not ended. So it's giving 5. The other way to span statement over multiple lines is using backslash, not the normal division operator. Backslash will be considered as line continuation character. So whenever you want to continue the same statement in the next line, you can just say 2 plus backslash, then go to next line and type 3. Once you press enter here, it will give you the result of 2 plus 3. Then comments. I hope by now you must have been familiar with the commands in Python. Whenever Python come across this symbol called hash, this hash symbol comes, Python will treat everything in that particular line which comes after this symbol as comment, and it will ignore whatever is written over there. As you can see here, Python ignores this sentence because of this hash symbol. Similarly, I have an expression here, and at the end of the expression, what I am doing, hash convert 212 degrees Fahrenheit to Celsius. So I'm saying what is being done in this expression, but Python interpreter ignores this statement as it encounters a hash here. So whenever you're using comment, you have to, all the comment had to start with hash, and it's considered as single line comment in Python. Every language is governed by its own set of rules and regulations. That's called as syntax. But every programming language is also governed by certain set of rules and regulations by the community of people who will be using that language. They are called as best practices. So these are some of the best practices for writing Python code. I'll just mention a few. So always put a space before and after every binary operator. This will make your expressions more readable, more understandable. Then while naming the variable, use names which are relevant to the context. That is, use names which is relevant to what are the variables which you are using for. That is, the name should be relevant to the purpose of the variable. For example, if you're storing the Celsius values, you can give the name as Celsius. You're storing the average value of something, you can give the name as average or final result. And it's better to avoid names like new var or var1, id1. All these things can be avoided. And also it's good to use consistent names, like if you're using maximum at one place and max val in another, or max val at one place and max val like without underscore or with underscore. If you're making some little changes like this will this may make you confused, or this may make someone else reading your program confused. So instead you can follow a consistent pattern in naming the variable. That will be easy for you and also for other people who will be reading your code. There are certain style guide for Python which is available in this particular web page, http www.python.org dev peps pep0008. Here these are style guidelines. These are considered as good practices while writing Python code by a community of people who are uh, into Python programming language. So it's always better to work as a community. If you're writing Python code, it's always good to see what other peoples who are also writing the code, what they are following and what is considered as good practice, and go ahead with that. So as we reach the end of the session, I'll just brief on what all we discussed today. An operating system is a program which manages computers' hardware on behalf of other programs. That means operating system is the special software which has direct access to hardware, and it interacts with both hardware as well as application programs. Then an interpreter or virtual machine is a program that sits on top of the operating system and runs your programs for you. Python interpreter sits on top of the operating system and runs Python programs for us. Python shell is an interpreter translating your Python statements into language the operating system understands and translates the results sent back from the operating system in the Python statement. Programs are made up of statements and instructions, and simple expression like 3 plus 4 and Celsius is equal to 20. All these kind of simple expressions are easy to evaluate in Python shell. And there are two different types data types of numeric data types which we discussed in today's session, that is integer and float. Integer is the whole numbers, whereas float are nothing but the approximations to real numbers. Then Python expression evaluation, that will be done by applying higher precedence operator first and then the lower precedence operator. This order of the operator while evaluating the expression can be changed by using parentheses. Then Python stores every value in computer memory, and every variable will be pointing to a particular memory where the value is stored. Variables are created by executing assignment statements which are on the right side of the assignment operator. Variables contain memory address of values, and variables must be assigned values before they are used in expressions. If I'm using an expression x on the right side of the assignment operator, I have to assign a value to it before using it in the expression. So for this Python series, I'm referring to a book called Practical Programming, second edition, An Introduction to Computer Science Using Python 3 by Paul Grease, Jennifer Campbell, Jason Montojo. This is a very good book. Even you can go through this. Thanks for watching. See you in the next video.